Alrighty, so the first thing you want to do when you have a stoichiometry problem like this is to balance the equation. So we're going to start off just by balancing this chemical equation, okay? So again, at any point, if you're cool with the balancing, you can just go ahead and balance, but I'm going to take a step by step for the people that need a little help. We're just going to write down the elements that we see in the equation. We got sodium, we got hydrogen, and we got oxygen. So the capital letters. And we're just going to make a table so that we can count how many of each element we have on the left and the right sides, okay? Okay, so if we look at the left side, how many sodiums do I have? Yeah, just one. How many hydrogens? Two. And oxygens? One. Good. Okay, we go to the right side. We should have one sodium, one oxygen, but how many hydrogens do I have? Two. Not two. Oh, wait. Three. Yeah, there's two in H2, but there's a third one right here. So just make sure you're careful when they're split up like this because it will mess up your balancing. We have three. It's all good. I make mistakes all the time too. Okay, so we got to balance the hydrogen, and so we need to add hydrogen to the left side. So I need to add the entire molecule, which is H2O. Okay, that's going to change my numbers a little bit. How many hydrogens do I have on the left side now? Four. And oxygens? Two. Good. Wow, you guys are master balancers now. Okay. All right, so we go to the right side. Since we're missing hydrogen, we can either add NaOH or H2, but if you notice, we're missing H and O. So which one should I add, NaOH or H2? Do I even need to teach this now? I don't even need to teach. We can just give you the test, right? No. Okay. Actually, when did I ever teach? That's the real question. All right, and then we add an Na. It's true. Yeah, how about I just take a nap and I just give you the exam and you guys take it? Yeah, Alice can take over. I believe in Alice. So 2, 2, 10, 2. Okay, so that's how we balance the equation. Okay, before we move on, any questions on the balancing part? Pretty easy, okay. You guys say that. Watch me give you hard balancing. Okay, so the next thing we want to do is we want to find the molar mass of the important chemicals. Okay, so I'm going to erase this real quick, but we want to find out which chemicals are important in this problem and which ones are not. So if we take a look at the problem, okay, we are looking for grams of Na. That means Na is going to be an important chemical, right? Because that's what we're looking for. This is the end point of the problem. And then our starting number is 100 grams of NaOH. This is our starting number, our given. So this one is important. And since we have excess H2O, what does that mean? Yeah, we have so much, we don't have to care about water. We can ignore this. All right, we can also ignore the H2 because we're only going to be looking for Na and NaOH, so we can actually ignore H2 here as well. Thanks. Okay, so the only two chemicals that are important in this problem are Na and NaOH. So we're going to find the molar mass of these guys right here. Okay, so we're going to go to the periodic table. We're going to look at Na. What is the molar mass of Na? Yeah, 22.99, which is basically the same thing as 23. So we're just going to write 23 for the molar mass. Na has a molar mass of 23 grams per mole. Okay. Now we can do NaOH. We just said Na is 23. So if we look at oxygen and hydrogen and we add it up, we can get NaOH. So let's go to the periodic table again. If we look at hydrogen first, what's the molar mass of hydrogen? 1, and oxygen is 16 and 17. So if we add them all up, we should get 40. Oh, yeah. So if we combine all of it, yeah. 17 for 16 and 1, and then 23, you add them all up and you should get 40. Okay, so that's step 2. Before we go into the dimensional analysis, you guys have any questions? Okay. All right. Last part is the fractions, the dimensional analysis. We're going to take the starting number, which is 100 grams of NaOH. And then how many fractions should we set up? 3. 3, yeah. Tree. Okay, yes. And what's the sound that we make? Yeah, gumamaga. Gumamama. Wait, gumamaga. 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 Okay, so that means the tops we're gonna put g, which is grams, m, which is moles, m, which is moles, and g, which is grams. Okay, gumamaga. Alrighty, now what we're gonna do is we're gonna fill in the fractions, but if you guys remember or noticed last time we did this, the final fraction is gonna be what we're looking for, right? Grams of Na. And if you guys notice the pattern, the first two fractions are about the same chemical, and the last two fractions are about the same chemical. So that's another tip that you guys can use just to fill out more of the fractions, just to ensure that you always get the correct answer, okay? The first two fractions are about the same chemical, and the last two fractions are about the same chemical. Okay, let's start canceling things out. I want to get rid of grams of NaOH, so I'm going to put grams of NaOH on the bottom. Since I have grams and moles on the same fraction, where do I get the numbers from? Anyone remember? Molar mass, yeah. Okay, so periodic table basically. So NaOH is 40. Now, if you notice, 40 is next to grams, right? So where should I put 40 on this fraction? The bottom, yeah, next to grams. And we know that it's equal to 1 mole. Remember, because molar mass is always grams equals 1 mole. So we put 1 next to moles. The grams can cancel out, and we can move on to the next one. Okay, so just get the numbers from the molar mass. Okay, next we're going to get rid of moles of NaOH. So I put moles of NaOH on the bottom. Okay, where do I get the numbers for this second fraction? Yeah, the balanced equation. Okay, so we just look at the equation for Na and NaOH. Na has a 2 in front of it, so we put a 2 next to Na. NaOH has a 2 in front of it, so we put a 2 there. Exactly. The moles cancel out, and the 2's cancel out. So you can actually just skip that fraction when you do the math. And then last but not least, we have moles of Na on the bottom. Okay, I already asked this question, but if I have grams and moles, where do I get the numbers from? Molar mass, good. Okay, so we just get the molar mass of Na, which is 23. Where should I put the 23 on this fraction? Top, yeah, next to grams, and I put 1 next to moles. The moles cancels out, and there you go. We can just plug it into the calculator, and we will be all done. Okay, so for the multiplying and the dividing, just multiply everything on the top, divide everything on the bottom. So I punch in 100. What should I do with the 40? Divide, since it's on the bottom. And what should I do with the 23? Okay, and then we get a final answer of 57.5. So your answer is 57.5 grams of Na, because that's the only unit of measurement left over, okay? And there you go. That's how you do Stoich. Okay, so for this unit, I'm actually not going to make it much more difficult than this. It does get harder going forward, but we'll get into that later. So if you guys are pretty comfortable doing these problems, you should be in good shape for the lab. And we'll be taking the exam for this unit right before finals week. And then for finals, we're just going to do a very easy research assignment. If you follow the directions, 100% good way to just boost up your grade at the end of the semester, okay? Alrighty, so I'll give you guys the rest of the class period to work on your assignment. Now, I did print out a couple of the assignments. If you want to just do it on a physical piece of paper, I have it up here. You guys can grab one. But I'm going to give you guys the rest of the class period to work on the assignment. You can check your answers with me if you want. And if you have any questions, please let me know. Okay, good luck, guys. Ow, 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 ow.